Ever wondered how your computer processes information? The answer lies in a small but powerful component known as the Central Processing Unit, or CPU. This tiny piece of technology is essentially the brain of your computer. It's responsible for interpreting and executing most of the commands from the computer's hardware and software, turning lines of code into actions that make our computer function. Think of it as the conductor of an orchestra, coordinating all the different parts to create a harmonious symphony. It receives instructions from the computer's memory, interprets what needs to be done, and then carries out those tasks. Whether you're writing a document, browsing the internet, or playing a video game, the CPU is hard at work behind the scenes, making it all possible. So next time you're sitting at your computer, take a moment to appreciate the brain power at work. In essence, the CPU is the primary element that interprets and executes instructions. Imagine if you could peek inside your computer, what would you find? Well, at the heart of your computer is the Central Processing Unit, or CPU. It's like the brain of your computer, overseeing all the computations and controls that make your computer function. Today we're going to take a closer look at the architecture of the CPU and understand its core components. First up is the Arithmetic Logic Unit, or the ALU. As the name suggests, the ALU performs all the mathematical and logical operations. Whether you're crunching numbers for a spreadsheet or playing your favorite video game, the ALU is hard at work, adding, subtracting, multiplying, and dividing numbers, and performing logical operations like comparing two numbers to see which one is larger. Next comes the Control Unit, or CU. This is the traffic cop of the CPU. It directs the flow of data within the CPU and even to and from other components of the computer. The CU ensures that instructions and data get to where they need to be, when they need to be there. It reads the instructions of the program you're running, decodes them, and then executes them, controlling the entire operation. Last but not least, there's the Memory Unit. This is the CPU's internal storage. It's where data or instructions are held temporarily while they're being processed. The Memory Unit is like the CPU's scratch pad, a place where it can quickly jot down and retrieve information it needs to perform its tasks. Together, these components form the backbone of the CPU's architecture. Each plays a vital role in processing the vast amounts of data that our computers handle every second. The ALU does the math, the CU directs the traffic, and the Memory Unit holds the information in place. As you can see, each component of the CPU has a specific function that contributes to the overall processing of data. Have you ever heard of microprocessors? Well, these tiny marvels are the power behind every computer operation you perform. They're like the engine of your car, but for your computer. Let's dive into the fascinating world of microprocessors and understand their incredible role in modern computing. Microprocessors, at their core, are integrated circuits. Think of them as complex jigsaw puzzles where each piece has a specific role in the grand scheme of things. They contain the functions of a central processing unit, or CPU, but instead of being spread across a room-sized machine like in the early days of computing, these functions are now condensed onto a single chip or a few linked chips. This miniaturization is what makes our modern compact computer systems possible. In essence, a microprocessor is a multi-purpose, programmable device that accepts digital data, processes it according to instructions stored in its memory, and provides results. It's the brains behind every click, every command, and every operation your computer performs. From surfing the web to editing a spreadsheet, it's all made possible by the magic of microprocessors. But what makes them so important? Well, the microprocessor is the heart of any computing device. Without it, your computer would be nothing more than a box of wires and lights. It's the microprocessor that interprets and carries out the instructions that operate your computer, allowing you to interact with your device in meaningful ways. They're also incredibly adaptable. While originally designed for computing, microprocessors have expanded their reach into nearly every aspect of our lives. From your smartphone to your smart fridge, from your car's navigation system to the International Space Station, microprocessors are the unsung heroes, making our modern digital world tick. So, the next time you're typing away at your keyboard or swiping through your smartphone, remember the magic of microprocessors. These minute marvels are working tirelessly, interpreting and executing millions of instructions every second, all to ensure smooth operation and to make your digital life possible. So the tiny microprocessor in your computer is working tirelessly to ensure smooth operation. So, how does the CPU process information? Well, let's dive right into it. It all starts with what we call the machine cycle, a four-step process that's as rhythmic and consistent as a heartbeat. Fetch, decode, execute, and store. These 4 steps are the lifeblood of any CPU's functionality. Let's start with fetch. This is where the CPU reaches out and grabs the data it needs to process. It's like a chef gathering ingredients before starting to cook. The CPU pulls the data from the memory, ready to prepare it for processing. Next up is decode. The CPU, now in possession of the data, needs to understand what it's supposed to do with it. It's like our chef reading the recipe. The CPU deciphers the instructions encoded within the data, determining what operation needs to be performed. Third, we have execute. This is where the magic happens. The CPU, having fetched the ingredients and read the recipe, now starts to cook. In other words, it performs the operation that was specified in the decode step. Whether it's addition, subtraction, comparison, or another operation, the CPU gets it done. Finally, we come to store. Once the CPU has executed the operation, it needs to put the results somewhere. So it stores the processed data back into the memory. It's like our chef plating up the meal, ready to be served. And then the cycle begins again. Fetch, decode, execute, store. Over and over, this 4-step dance plays out within your computer faster than the blink of an eye. It's the core of how a CPU processes information, turning raw data into meaningful results. And that, my friends, is how a CPU processes information step by step. The CPU's intricate dance of fetch, decode, execute, and store is a marvel to behold, a testament to the power and sophistication of modern computing. And to think, all of this happens in the blink of an eye, hidden away in the heart of your computer. Ever wondered why some computers are faster than others? Well, a lot of it boils down to the speed of the CPU, or central processing unit. This is influenced by several factors. First up, we have clock speed. This is the rate at which a CPU can complete processing cycles. It's a bit like the heartbeat of the CPU. The faster the clock speed, the more operations the CPU can perform in a given time. Then we have the number of cores. Imagine a 1-lane highway versus a 4-lane highway. More lanes mean more cars can travel at the same time. Similarly, more cores mean more tasks can be processed simultaneously. Next, we consider cache size. A larger cache allows a CPU to store more data close at hand, speeding up processing times. Finally, the instruction set impacts speed. A CPU with a complex instruction set can perform more sophisticated operations, further enhancing performance. Remember, the speed of your CPU can greatly influence your computer's performance. The CPU is more than just a piece of hardware. It's the heart and soul of your computer. It's the captain of the ship, guiding the vessel through the vast ocean of data. It's the maestro, coordinating the symphony of operations that bring your computer to life. It's the nerve center, processing information and making split-second decisions that affect every aspect of your computing experience. Let's take a moment to recap the main points we've discussed. We've taken a deep dive into the world of CPUs, exploring their architecture, understanding the magic of microprocessors, dissecting the steps of processing, and marveling at the sheer speed at which these tasks are accomplished. The CPU's architecture, with its cores and threads, sets the stage for its potential performance. The microprocessor, the heart of the CPU, is a marvel of technology, composed of billions of transistors that work together to process your information. The steps of processing, encompassing fetching, decoding, executing, and writing back, form the backbone of the CPU's operations. And the speed of a CPU, measured in gigahertz, determines how quickly your computer can perform tasks. But the CPU is more than the sum of its parts. It's the linchpin that holds your computer system together. Without it, your computer would be a ship without a captain, a symphony without a maestro, a nerve center without a brain. It's the driving force that powers everything from the operating system to the applications you use every day. So why does this matter? Because understanding the CPU helps you appreciate the complexity and ingenuity behind the technology we often take for granted. It's like peeking behind the curtain and seeing the wizard at work, pulling the levers and pushing the buttons that make our digital world go round. So, the next time you use your computer, remember it's the CPU that's making it all possible. It's the unsung hero of the digital age, tirelessly working behind the scenes to make your computing experience seamless and intuitive.